When the facts bend reality, this is beyond plausible.
Chesapeake Bay is the largest estuary in the United States and the third largest in the world, with an area of over 64,000 square miles. The Chesapeake Bay watershed includes parts of New York, Pennsylvania, Delaware, Maryland, West Virginia, and the District of Columbia. This area is home to 18 million people and 3,600 species of plants and animals. Chesapeake Bay is considered one of the most biologically active and productive estuaries on the planet. Despite being a biodiversity hotspot, Chesapeake Bay needs human assistance. After centuries of overexploitation, pollution, disease, and recently climate change, Chesapeake Bay is struggling to maintain life in its ecosystem. For decades, Chesapeake Bay has attracted national attention as a research area for implementing environmental regulations and ecosystem restoration projects. Universities consider this an important research site. Governments at all levels and non-governmental organizations are collaborating to provide solutions for the biggest threats to Chesapeake. Currently, Chesapeake Bay is beginning to show signs of recovery and overall health. However, there are still doubts whether the bay will continue to improve if pollution reduction targets are not met, or if funding for research and restoration is cut. In this video, let's explore the journey across the Chesapeake Bay watershed and learn about resilient habitats and wildlife. From burning fossil fuels in daily life, large amounts of CO2 are released into the atmosphere. Never in human history has CO2 concentration been this high. Forests are one of the best solutions to reduce global CO2 emissions. In previous centuries, forests covered 95% of the watershed. Currently, only about 57% remains. Through photosynthesis, plants absorb CO2 as part of their respiration process. The product of plant respiration is the oxygen we breathe. Competing for sunlight and available resources, forests form dense canopies that prevent light from reaching the ground. When a tree dies, it creates a gap in the canopy. These gaps allow saplings and new species to occupy the next stage of ecological succession. With the remaining forests, they not only absorb CO2, but also maintain incredible biodiversity. Before large-scale deforestation activities, squirrels could travel far south to Georgia without leaving the tree canopy. Now, with forest fragmentation, squirrels and many other species are confined to isolated wilderness areas. Eastern box turtles are one of the few terrestrial turtle species. These turtles prefer forest cover over water. However, it's no longer rare to see them cooling off in shallow water. What's interesting about these turtles is that gender can be determined by eye color. Males have red eyes, while females have yellow or brown eyes. When the sun sets, some species seek shelter and end a long day. For other species, activity time is just beginning. Bats use echolocation to navigate in the dark. This ability helps them find food and avoid trees and obstacles. At night, bats consume thousands of insects like mosquitoes, moths, and many others. Unfortunately, these nocturnal creatures face threats from white nose syndrome, a deadly disease that has spread across more than half the continent. The disease causes infected bats to use up their winter fat reserves before spring arrives. Eventually, sick bats starve or freeze to death while searching for food. To reduce the spread of white nose syndrome, a national action plan has been implemented, aiming to provide guidelines for humans when approaching bat habitats, and disinfection procedures to prevent the disease from spreading to uninfected areas. Marshes provide crucial habitat for many species in the bay and other ecosystem services. These environments act like giant sponges, absorbing large amounts of water from floods and sea waves. In addition to retaining water, they also store excess nutrients and pollutants from the watershed, found mainly along the shores of the Chesapeake Bay and the tidal portions of rivers. Estuarine marshes form as tidal marshes. These are areas flooded by tides and adapted to higher salinity water levels. When the tide recedes, the marsh reveals a temporarily hidden world. Fiddler crabs are small crustaceans living in many areas of the Chesapeake Bay. Males have one large claw used for display and attraction during mating season. This waving motion fascinates potential mates but also attracts attention from same-sex rivals. When not competing for mating, fiddler crabs spend time on the marsh bottom foraging. With their small claws, these crabs collect algae and other organic matter from the sediment. While feeding, fiddler crabs excrete small spherical fecal pellets. These small mounds can be seen across the marsh bottom before the tide rises and washes them away. With the moon's gravitational pull on Earth, the tide rises and falls twice a day. This activity acts like a clock, helping fiddler crabs know when to leave and return home. The marshes here include freshwater marshes, non-tidal marshes, marshes along streams and rivers or ponds and lakes. Turtles gather on partially submerged logs, using the sun to warm their body temperature. These cold-blooded reptiles rely on lying on fallen trees and nearby banks to regulate their temperature. When young, Chesapeake turtles are omnivores, but as adults, they become herbivores. Year after year, critical habitats from forests to marshes and coasts are lost due to urbanization and rising sea levels. With the reduction of wild areas, animals like birds and insects can immediately feel many negative impacts. Birds from every habitat are affected. Even commonly seen birds are becoming less common. In the past 50 years, Northern American bird populations have declined by nearly 3 million, according to a new study from Cornell Lab of Ornithology. With the diversity of ecosystems the Chesapeake Bay watershed provides, this area is also seeing a sharp decline in bird numbers. In fall and winter, the Chesapeake Bay becomes a food source for one of the planet's largest bird migration routes. Hundreds of thousands to millions of birds seek shelter in these waters during winter. Like birds, insects are also experiencing a major decline. Insect numbers have dropped sharply due to unsustainable practices from modern agriculture like pesticides, habitat loss, and disease. 3/4 of the world's flowering plants and 35% of global food supplies depend on pollinators. Scientists estimate that for every 3 bites of food we consume, one is made possible by pollinators like bees, butterflies, moths, birds, bats, and many other insects. Insects are low on the trophic level, meaning everything higher up is affected by their rapid decline. Due to the Chesapeake Bay's location in the mid-Atlantic, it faces extreme weather events with devastating power like hurricanes. After Hurricane Dorian in 2019 devastated the Caribbean, it moved along the east coast, pushing large amounts of water inland. Coastal flooding, strong winds, and destruction followed. As first line of defense, lakes and marshes help reduce the storm. With their absorption capacity, marshes can help lessen the devastation of coastal flooding. Marsh plants play a crucial role in storm system management. Due to their dense grasses, they slow water speed through winding channels, allowing sediment to settle out of the water column. Over time, sediment accumulation helps marshes grow vertically in a process called accretion. Accretion is vital for the future of the Chesapeake Bay and its marshes. If the accretion rate cannot keep up with rising sea levels and land subsidence, flooding will become persistent and prolonged, causing marsh plants to die and decompose. Over time, exposed marsh bottoms will erode and turn into vast mudflats and open waters, making the area prone to habitat loss and destruction, leading to dead zones. Dead zones are areas where dissolved oxygen in the water is nearly non-existent. Algae absorb excess nutrients and form areas of high algal density, called algal blooms. These blooms block significant light from penetrating the water column. In the Chesapeake Bay, aquatic plants were once found at depths of 2 meters. Today, with increased pollution raising the bay's turbidity, they are only found up to 1 meter deep. This significant reduction in spatial distribution puts great pressure on the viability of aquatic plants in an already stressed environment. When algae die, they sink to the bay bottom and begin to decompose. During decomposition, bacteria consume large amounts of dissolved oxygen to break down organic matter, releasing methane and carbon dioxide. With limited oxygen, the water gradually becomes dead. But over time, environmental and meteorological conditions will eventually reach the threshold allowing oxygen-rich water to return. Chesapeake Bay is a vast ecosystem where all habitats and wildlife are part of a huge interconnected ecological network. When these connections are disrupted, it creates ripple effects throughout the region. This affects not only wildlife but also the people who depend on this place. Through grassroots environmental activities, research, regulations, NGOs, and the establishment of the Chesapeake Bay program, positive changes are beginning. Research shows that implementing regulations to limit runoff from wastewater treatment plants, agriculture, and urban areas significantly reduces the amount of nitrogen and phosphorus entering the bay. This change is sufficient to reduce turbidity and algal blooms while enhancing the abundance of marsh ecosystems, oysters, and aquatic plants. In Chesapeake Bay, the restoration and recovery of seagrass has become the world's largest aquatic plant restoration effort. Thanks to strict enforcement of blue crab and oyster harvesting regulations, their populations have now begun to recover. In the 2019 winter survey of blue crabs, researchers recorded the 8th highest population level in the past 30 years. Such success stories are not rare. Each year, more reports from research and environmental organizations show that wildlife is returning. The fate of Chesapeake Bay depends on maintaining regulations, project funding, and human willpower. Humans now have the ability to save Chesapeake Bay or destroy it. What are your impressions of America's largest estuary? Please share your thoughts in the comments section.
Curious? Subscribe and step through the next anomaly.